All right, my little angels. Um, let's emphasize a couple things. We're pretty good, I think. Homeworks. I don't look to see if you're right or wrong. I don't. I try. Try. If you get stuck on something, try something else. Fake it. Fake it. All I'm going to look. It's 100% effort. If you look like you've tried it, you're going to get your full points. Okay with that? I would much rather you look like you tried it than copy an answer. So, I mean, I won't know the difference a lot of times, but just understand that. Okay, those 3 points are not that big of a deal. They're not going to make or break your grade. They're going to help your 89s to 90s, your 79s to 80s. They're going to help your 80s drop down, right? They're going to help those. But if you're right in the middle part, probably not going to make a whole lot of difference, truth be told. Okay, between that, quizzes and tests are making up the majority. And so if you can't do the homework, you can't do the quizzes. And if you can't do the quizzes, you can't do the tests. And if you can't do the test, you're not going to do well in class, bottom line. So it kind of is a stair-step effect. So I'm starting to treat this, I treat you guys pretty much like college classes. They don't care if you do any homework. They don't care. You're going to get 4 grades for most of the time. You're going to get 4 grades. A midterm and a final, and then a quarter and a quarter, 4 tests for the most part. Sometimes they'll change all that. That kind of depends. So we're given a bunch of homework, not a bunch, but several homework grades to lead up to those. Just kind of understand all that stuff, okay? So if you can fake it, upload it, I'm going to look, spot check them, kind of look through them to see that you've done them. The first couple I'll check even harder, but after so long, I'll know who I need to check and who I don't. So if you want to do a real good job, start faking it early. Truth be told, okay? Sometimes I'll just look, and if there's 29 students in here now, if I see 29 students have turned it in, I may not even look. I'll just put in 3 points and go to town. Y'all kind of make sense with that, okay? I mean, it's on you. I put a lot of ownership on you guys for the homework. And then when we get to class today, because I haven't asked anything for any homework questions yet, that's when we cover anything that you got stumped on, okay? If you look at my answer sheet, sometimes it doesn't make sense. Heck, sometimes you can't read it. So just understand all that stuff, okay? And when I do look at it, if I notice like you've uploaded it something a little weird, I'll just send you something, but I'm not, until a little while, I'm not that, as long as you get it uploaded, I'll get it figured out. It just takes me more time, and time is precious to me. So if you upload them as JPEGs and there's 5 pages of homework, I got to open them separately. I got to open it up, look at it, then I got to open up the next one, look at it. If it's all one file as a PDF, I can just open it up and scroll through it real quickly. Kind of makes sense. So I'm just selfish in that matter. My time is important to me. So, however, I need to make sure that you guys are doing what you're doing, and that's part of my time. Okay. So homeworks, we're okay with all that stuff. Just get them uploaded and get them in there, and however it is. And if there's any issues with it, like I can't get it done, just send me a quick something like, I've tried and tried and tried, I have issues uploading it, right? Okay, that's fine. Just get it to me at some point, as long as I know you've tried it. If there's nothing there, it doesn't even look like you tried to me, okay? All right, 1.1, changes. You'll start seeing, guys, a lot of this stuff carries over to each lesson. Right? The concavity, increasing, decreasing. It's a really, really big deal in this class. And it's going to carry throughout the entire year. And that's why I spent as much time as I did with 1.1, although hoping it wasn't that difficult of a lesson. Y'all did see on Wednesday, we're going to do a little quiz over 1.1 through 1.5. Okay? So I'll teach 1.6, and then we'll do a quiz. The quiz is on your computer. Your quiz is on your computer, so make sure you bring your Chromebooks charged Wednesday, okay? Good enough with that. So if you can use a calculator, it's on the quiz. So you can click calculator. And if you can't, then you can't click calculator. But if you don't bring a Chromebook, that just messes everything up. Okay, 1.1. So now we're asking for any questions. I'll go through worksheet by worksheet And so this is where you guys input if you need any questions over 1.1. I'll give you a little bit of time. I know some of you guys need to get your worksheets out just to kind of look at anything over 1.1. Increasing, decreasing. Most of these were multiple choices. Increasing, positive increasing. Rate of change, negative. Pretty much that was everything. Increasing, decreasing, concavity. Everybody okay? Anything over 1.1. Nothing going once, going twice. Beautiful. I'll close it. 1.2. Give you a chance to look through something. Was that the one that you guys asked about? Was it 1.2 that we had that when I couldn't figure it out, and as soon as you guys left, I figured it out? Was that 1.2 or 1.3? It was 1.2. Let's see. Hit me. It was? It was 1.2? Which one was it? On the second, third, fourth. We need to renumber that, don't we? One B part, C part, 6, 7. Whoop, that doesn't have an 8. Is it like the last page? It was A. I reordered mine. I'm sorry. I reordered them like I'm supposed to. That one? Oh, yeah. Find C. Find C a constant. This is kind of an AP-ish type of question. Okay. So the way I did it is different than the way the other teachers did it. It's actually different than the way than Mr. Passwater did it. I don't know. Anyway. So I cheat a lot. I don't write N or G or F of it. I just say Y. I don't recommend you doing that because at the end, if you got Y equals, then they're going to ding you. But I'm lazy. The average rate of change from C to 5, and that's equals from C to 5 is equal to 3. So the slope is equal to 3, and C is some constant. So we know that it's y minus y over x minus x. Y minus y over x minus x. And so I changed this C to x again. At the very end of it, I'll say C equals. But I'm just a XY type person. So y minus y. Well, if I plug in 5 for this, 25 minus 4 is 21. So the y value is 21, but when I plug in x, then I get x squared minus 4. So that's the x value for x. And so now it's still y minus y over x minus x. So y minus y, 21 minus 5, whoops, over x minus x. Yep, what'd I do wrong?
You did y value minus the x value.
Oh, yeah. This is not a point. Thank you. X value. So it was a x. Thank you. I knew something was going wrong because that was going to be hard and tough. There. That's the point, right? X, Y, and 521. There you go. Thank you. First mistake this year. Erase. I knew something was going wrong. Now I got y minus y, 21 minus x squared minus 4. This is starting to get good algebra stuff. We're going to get good algebra stuff today too. Y over x minus x. And that should be equal to 3 over 1 or 3 or whatever you want it to be. Anytime I have a fraction, I like it to be equal to a fraction, just because that helps me. Some people might say cross multiply here. Some people might say simplify. Some people might say multiply by a common denominator. That's what I like better because cross multiplying is multiplying by a common denominator. Let's simplify a little bit. Let me change these colors so it looks a little better. So this is now 21 minus x squared plus 4. That minus goes there and that minus goes there, plus 4. 5 minus x. 21 plus 4 is 25. So I'm still simplifying. So now I got 25 minus x squared over 5 minus x. Now, Mr. Passwater, Ms. Gross factored that because that's a difference of squares. 5 minus x, 5 plus x. You got to be able to see that. You should know that like the back of your hands. Okay, factoring quadratics, you got to know how to do that. That comes up today. You just got to know how to do those. And because that's 5 minus x and 5 plus x, the 5 minus x and the 5 minus x cancel. I didn't do it that way because I don't like canceling x's. That's just me. So I multiplied both sides by 5 minus x. And if I multiply this side over here by 5 minus x, then they cancel out. So I'm left with, let me change colors again, try to clear this up. I'm left with 25 minus x squared. And now multiply that side over there by 5 minus x. I get 15 minus 3x. And now we got a quadratic we have to solve. So I move the x squared over here because I don't ever like a negative x squared. The negative 3x is already there. And that 25 is going to go over there and make minus 10. And now you can use the zero product property, factor this and solve it. You hope it factors. If it doesn't factor, you got to use the quadratic formula. Most of the time they factor for us. In pre-cal, most of the time they're going to factor for us. And so this factors into x minus 5, x plus 2. Negative 5, positive 2 gives me the negative 10, and the negative 5 and the 2 gives me the negative 3. So x equals 5 or negative 2. Those are the 2 times where the slope is 3. It's a quadratic, right? So there's 2 times where the slope is 3, but 5 can't work because 5 minus 5 is 0. So that's where it's negative 2. And if you factored things out, it would have done the same thing. There's more than one way to do these problems. Each way is no more right or wrong. It doesn't matter. I don't really care how you get there. Okay. Anything else over this one? Anything? Speak now, forever hold your P's and Q's. 1-3. Had a couple emails last night over one of these. I don't remember which one it was, but I just said we'll get to it in class. 1-3, anything? Linear, quadratic, neither. I posted the answers a little late last night. I apologize for that, but hopefully it was still enough time for you to be able to check and see if you got them right or wrong. I hope I got them right. Y'all know it's very possible I missed one. Anything? Find the average rate of change, find the increasing, decreasing. Anything? Hit me. I can. Any other questions? That's one of my little jokes. Can you? I can do them all. You got another question? You want me to work out number 12? Okay. That one? Okay. Sometimes they'll say, can you go over it? And I'll sit there and go, whew. No, ain't no way I can go over that. I can go under it. Okay. What was this one? We had to find K? What, they had to tell me something else about it, I'm sure. Table gives a linear. So it's a linear function, okay? So it's a linear function, you know the slopes have to be the same. So between here and here, it's k minus 1. Between here and here, it's 16 minus k. Between here and here, that's 6. I'm just doing y minus y. Okay, just did y minus y. And then over here, I got to do x minus x. So that's 2. This is 3, and that's 2. So this one kind of is different because it's one of the few ones they did not go consistently over here. A lot of them like to go consistently, but they're not. So this slope from here to here is, let me change colors again, try to clear it up. Red is k minus 1 over 2. This slope is k minus 16 minus k over 3. And then this slope is 6 over 2. Well, that slope is 3. So that's nice. If this slope is 3 and they want it linear, then this slope has to be 3, or this slope has to be 3. They both got to be 3. And so you can set this one equal to 3 and solve for k, or you can set this one equal to 3 and solve for k. Either way, you should get the same value. I think the top one has smaller numbers, so I'm going to use it. So we just do k minus 1 over 2 equals 3 over 1. And multiply both sides by 2 to get rid of that denominator. So you get k minus 1 is equal to 6. Move that 1 over there and you get 7. K equals 7. Good? You'll do this stuff a lot. Be careful. A lot of times these are consistent over here. But like that one right there, it wasn't. And so when it's not, that will mess you up if you're not careful. Okay? Yes, ma'am.
Can you go over number 9? Oh, I mean,
Page which one?
page 2.
This one? That one? 9. Quadratic. Quadratic. Quadratic means the rate of change is the same. K plus 2, 12 minus K, 4, 2. Point 4, point 4, point 4, point 4. Okay with all that? And if it's quadratic, those have to be the same. How did I do this last night? Can I just do 4 minus, yeah, that's what I can do. 12 minus K. This is Y minus Y. I can't say 0 though. How did I do this? Hit me.
So if it goes up like this, it's 12 minus 6.
Oh, that's how I did it. I made it real easy, right? If this is going up by 2 every time, that's 2, that's 4, so this has to be 6, this has to be 8. So if this is 6, this has to be 6. So 12 minus K equals 6. K, 6. Thanks. I get nervous when I get in front of you guys sometimes. Draw blanks. If this change is 2, that change has to be 2, that change has to be 2. So this has to be 6, that has to be 8. So I could have said K plus 2 equals 8. That was actually easier. Move the 2 to the other side and still would have got 6. You got to get the same thing for K. Beautiful. Anything else on that one? Happy, happy, joy, joy? Polynomials. Degrees, leading coefficients, extremas, where's the ones you had to draw a graph? Infinite solutions. Just because yours may not look like mine does not mean it's wrong. Okay? There's infinite ways to draw that. Infinite ways to draw that. So yours does not have to look like mine. Mine did not look like Miss Gross's. Make sure you put arrows on them, though, where they need to have arrows. Because if you don't put arrows, then they have absolute minimums or maximums. So make sure you put arrows where arrows need to be. Good, good, good. Anything? 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 Yes, sir.
If X is in the exponent,
Okay.
is it a polynomial?
No.
And is it a negative dimension?
Correct. For it to be a polynomial, the exponents must be real numbers. Hold on. Hold on. That's the wrong terminology. They have to be integers. No, they have to be whole numbers. How about that? Whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or somebody said positive integers. They can't be negative. They can't be negative. They can't be fractions. They can't be variables. Exponents. And if there's any one of them anywhere, doesn't matter where, any one of them anywhere, it's not a polynomial. It's something else. It's something else. If the x is in the exponent, it's exponential. Yeah. If the x is in the exponent and there's an x squared, that really starts messing things up. We don't see anything like that. What else? Anything else? Yes, sir?
Number 15 and 16. How do you argue that?
Where am I at? What page? Which one? Those?
Yeah, how do you argue it? I know it is.
We'll talk. Even degree. So because it's an even degree and the leading coefficient is positive, I think that's all you need to argue it. Even degrees have maxes or minimums. Odd degrees don't have it. So even degree, positive, you guys know that it's going to do all kinds of crazy things, but at some point over here, at some point over here, it has to go up and down. So at some point, we've got to hit a minimum somewhere. Somewhere. You have to. It's impossible to go from here to here without turning at least once. And if you want to turn here and then it goes back down, at some point, though, you got to quit turning and you got to start going up. And that really can only have a max of 3 turns. If it's a fourth degree polynomial, it can have a max of 3 terms. It can only have a max of 4 zeros. We'll talk about that today too, but you guys should somewhat remember that a little bit from that. So that's an even degree positive leading coefficient. Even degree positive leading coefficient, it has to have an absolute min. And I think that's all you need to explain it. I don't know how else you do explain it other than saying it has to. This one is a odd degree, so it does not have an absolute max or min, right? And it's negative. So if it's negative, it's going downhill. Whoop, that's sorry. That's straight. It's going downhill. Now, it's not straight. It's not linear, but I just treat it like linear because that's what all I care about is the end behavior. So it may do all kinds of crazy stuff, but at some point it's got to start going back down. It's got to start way high and it's got to go way down low. That means that it has to cross the x-axis. It has to have at least 1 0. Evens don't have to have a 0. They don't have to. Let me rephrase that. Don't have to have a real 0. They can have imaginary zeros. Great question. Somebody had a hand up earlier. Yeah, hit me.
Did you go over 21? What are they graphing with?
I went over it. Where was it at? Where was it at? This one? Sketch a polynomial provided, okay, from negative infinity to infinity. So negative infinity to infinity. That means I'm starting all the way to the left and going all the way to the right. Has 1 local max. 2 global minimum. They have to be equal. They got to be equal. Global means like that's the lowest point it could possibly be. Concave up, concave up, concave up, concave up, turning, concave down. Concave down, concave down, concave down, turning. Concave up, 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 up. Please tell me it had 2 points of inflection. Okay. If it had something else, that'd be tough. 1 local max, 2 global mins. Good? And like I said, 29 of you cats in here and y'all could have 29 different graphs. But you better have an arrow here and you better have an arrow here because that's the only, I mean, you got to have that. And then you got to have 2 of those that are equal. But where, it doesn't matter. Okay? Where, it doesn't matter. But they got to be equal. Yes, sir.
For number 22, when it says 1 term is flexible, that's when we relative to our absolute extremity. Would that just go like down and straight?
1 point of inflection, no relative extrema, no absolute extrema. I think that's like a cubic. Concave down, concave up. And I don't have any maxes or mins because this never went back down, and so that'd be like a cubic or a 5th degree or a, basically it's a odd degree with nothing else with it. I mean, I guess it could have, let me rephrase that, an odd degree with no other variable. How about that? An odd degree with no other, and you could have gone this way. It didn't say which way it had to go. It just said it can't have any extrema, but it has to have a point of inflection. So that's concave down, concave up. Good? That means at some point in here, it's going to be a horizontal slope, or it's going to have a horizontal tangent line at some point in there, because that's where it changes. when it changes to a horizontal slant. Good questions, great questions. Yes, no, maybe? We'll see. I'll look at homework tonight. If you got questions or something else or something you didn't remember in class, right? Just send me something, right? Oh, I was thinking about this. I didn't, or you're starting to study, right? And you forgot. I don't do a whole lot of review sheets. I'll be honest with you. I don't do reviews. That's what homeworks are for. Homeworks are your reviews. Can I have a review sheet? Sure. I'll give you a blank homework sheet. I mean, I don't do reviews. If you feel like you need something else, okay? Look what I've done. I don't know if anybody's noticed this. I got other resources. It's right above the calendar. 2 links. 1.1 through 1.5. Bunch of stuff. And then here's another one over here. These are all YouTube videos. Uh-oh. Oh, there it is. Again, this is the whole year. That's why I left it there. 1.1 through 1.5. Okay? So, if you don't like the way I've done it, or you want somebody else to explain it, or you want to hear it a different way, there's that. Okay with that? Or, like I said, send me an email. If you get confused about something, send me an email. Or come by during flexes. We got flexes now. I open up my flexes are straight study halls. I put mass study hall. And if you got something and you can't get in because it's locked or something else, send me an email, because I leave room for my students to ask me. Because I get all kinds of students in here. Because it just says math help. And so who knows might sign up for it. But if my student needs in there, I leave a little bit of room for that. So just send me an email, hey, can you pull me? Yeah, I'll pull you. And if I pull you, then nobody else can pull you. Supposed to. Good enough with all that? Boom, 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 boom. Here we go. Whoop, whoop. 1.5. 1.5. Again, 90% of this you know. Yeah, 90. 85. There's some things you don't know. You don't know 100% of it. Okay? Of course, you know that 67.2% of all statistics are made up. Thanks, you caught that, didn't you? Including that one. Okay. Here we go. Polynomials. We're still into polynomials, guys. There's a lot of polynomials in Unit 1. A lot of polynomials in Unit 1. Given a polynomial, P of x, they like to do P of x for polynomials. P of a is equal to 0, then a is a 0 or a root or a x-intercept. They didn't say that. They all mean the same thing. Roots, zeros, x-intercepts, all those 3 things mean the same thing. Okay? A is a 0 and a root. If a is a real number, then if a is a 0 of p, then x minus a is a factor. Okay? So again, you guys should start thinking about the different factors and zeros. If I do let me do this, x minus 3, that's a factor. But that means that 3 is a 0, because it takes a positive 3 for that to be a 0. You just set the factor equal to 0 and solve for it. So factors and zeros. And then they start talking about multiplicity. And maybe you remember this word and maybe you don't. We're going to take it a little bit further maybe than what you remember, than just saying what they are, but I still think it's what you know. If x minus a is repeated n times, then it has a multiplicity of n. So if you see an x minus 3 and another x minus 3, then you know it's a multiplicity of 2. If there's another x minus 3, then it has a multiplicity of 3. And really all you care about is if it has an odd or even multiplicity. Okay? Typically, we know that the graph polynomial passes through the zeros. through the zeros on a graph. Typically, it passes through zeros on a graph. Typically, that's what it says. Typically, most of the time. Special occasions, it doesn't. However, when a multiplicity greater than 1, the graph will behave in different ways. Okay? You guys have learned about, I guess, even degrees or bounces. What do you call it? Y'all call them bounces? Bounces? That's what I've always called them. It just hits it and bounces right back up if it's even. If it's an odd degree, it crosses. However, if it's a third degree, it kind of really does a little bit different than the cross. It doesn't really just cross, it does the cubic thing. Okay? If it's a degree of 3, it doesn't cross it linearly, it crosses it cubically. Whereas if it's just a degree of 1, it does I don't want to say linearly, but it just crosses. It doesn't do anything. It doesn't curve it. Okay, that's what all this is saying. The function that, holy cow, negative 0.1, x plus 4, x plus 3, x minus 3 is graphed to the right. So there's the graph of that nasty thing. The multiplicity of a 0 is the multiplicity of a 0 is the degree of its factor. Is the degree of its factor. We can conclude that x is equal to negative 4 is a factor. Negative 4 is a factor. Negative 1 is a factor with a multiplicity of 3. And positive 3 is a factor with a multiplicity of 2. And over here you can see that positive 3 is a bounce. Negative 1 is like the cubic. And negative 4 is a cross. Because it has a multiplicity of 1, this has a multiplicity of 3, this has a multiplicity of 2. 1, 2, 3, 4, 5, 6. That's a 6-degree polynomial. 1x, 3 more x's, 2 more x's. That's a 6-degree polynomial. Thank goodness we didn't ask you to multiply that thing out. I would never want to do that. That would take forever. But that's a 6-degree polynomial. So one of those is going to be x to the 6th. It's a 6th degree. I don't know what the coefficient is, and I don't care. Except the coefficient's negative. At x equals 3, the multiplicity of 2, the graph is tangent to the x-axis. Oh, that's what they say. They don't say bounce. They say it's tangent to the x-axis. Because when it gets there, it has a tangent line of the x-axis. Boom. That means the slope is 0 right there. The slope is 0 right there. Positive, 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 0. Negative, 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 negative. Yeah. Okay. Whoop, arrows. For each of the following polynomials, determine the degree of the polynomial and find the real zeros and state the multiplicity. The degree. One, 2, 3, 4, 5, 6. I just count the number of x's. Count the number of x's. 3 x's, 1 x, 2 x's. 3, 4, 5, 6 degree. 6 degree. Zeros. Luckily, this is factored for me. 0, multiplicity of 3. That's multiplicity. Negative 1. Multiplicity of 1. And 4. Y'all understand that's not a difference of squares. Don't get confused on that. That's not a difference of squares. In order for that to be a difference of squares, it would have to be x squared minus 4. It's not. It's x minus 4 squared. That means there's an x minus 4 and another x minus 4. Like B. Red, whatever. Green. Let's do green. 1, 2, 3, 4, 5. It's also a 6-degree polynomial. Careful that first one, it's not factored. Uh-oh. But luckily, that's a difference of squares, which factors pretty easily. X minus 2, x plus 2. Ooh, that's tricky. That's x minus 2, that's x plus 2, and that's x minus 2. And that's x minus 2 with a degree of 4, and actually now it's x minus 2 with a degree of 5. So 2 degree 5, negative 2 degree 1. Those multiplicities better add up to the total degree. I'm saying degree, I'm sorry, that's multiplicity. That's multiplicity. That's multiplicity. Sorry, first mistake this year. Homeworks abbreviate, tests probably don't want to abbreviate. Spelling is not required. However, it's written right there. Last one, red, red, red. I want red. There it is. Yuck. Factor, 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 factor. You better get good at factoring. If it takes you a long time to factor, you will not finish tests. Okay? Get good at factoring. If you're having issues with factoring, let me know. I'm going to post, I'll post this lesson, the notes. I'll post the notes. I'll post this YouTube, and then you'll see a Delta Math. That's not required, but it's to help you factoring if you have issues factoring. Okay? There's a Delta Math that will help you factor. Take an X out first. Minus 3, minus 4. Boy, that's not, they're not real hard factoring typically. Minus 3 plus 2 minus 3 minus 4. You need to get good at those factoring. It should be almost that quick. I'm telling you, you're going to struggle in this class if you're not good at factoring. So get good at it somehow, some way, some form, some fashion. Watch it on the YouTube. Like I said, there's some. I'll have you a Delta Math, Khan Academy, whatever you got to do. 1, 2, 3, 4, 5. Fifth degree polynomial. Fifth degree polynomial. X equals 0, multiplicity of 1. X equals 3, multiplicity of 2. X equals negative 2, multiplicity of 1. X equals 4, multiplicity of 1. Sorry if those look like 7s. Yes, no, maybe? Any questions about something? Some polynomials have roots that contain imaginary numbers. This means you will not see them on the graph. Imaginary, complex, I don't know exactly what your teacher called them. You probably called them a little of both. Imaginary is typically a number all by itself, then complex is a number with it. Hit me.
Oh, I had a question about the.
Oh, I'm sorry.
So can we only count the x's, like if I went to do this after the factoring?
You could have done it at the beginning.
And you get a different answer.
If you multiply 3x to the third times x squared, you get x to the sixth. No, you don't. You get x to the fifth. That's fifth. It's 5. It's 5. I'm sorry. Yeah, if you multiply x cubed times x squared, you add exponents. And I don't care about all the others. I just need the two biggest ones. So if I multiplied this times this, it would be x to the fifth with a bunch of other crap. The graph of x squared plus 1 is shown to the right. To find the zeros, we set x squared plus 1 equal to 0. When you move x squared plus 1, you move the 1 over there, you take the square root of both sides, and the square root of negative 1 is I, but there's a plus and a minus. You got to do the plus and minus. You can't see it on the graph because it doesn't cross the x-axis for 1. It just looks like x squared, but it's moved up. All imaginary roots come in pairs. All imaginary roots come in pairs. If a plus bi is a root, then so is a minus bi. It's that middle number that changes, guys. The a doesn't change. The a doesn't change. So if that's a -2, that's a -2. The first number does not change. The second number changes. The second number changes. So determine its conjugate. We'll call them conjugates. Conjugate means you're changing that value. It's the opposite of it. So conjugate of 4i is -4i. The conjugate of 4i is -4i. The conjugate of -i is +i. All you're doing is changing the sign. The conjugate of 2 minus 3i, that's where the 2 stays the same. 2 plus 3i. If you FOIL it out, then those middle two cancel each other out. -4 minus 2i. Just change the second sign. Let me rephrase that. They could trick you. They could trick you. I don't think they will, but if they put something like 3i minus 1, the number should go first and then the imaginary goes second. Should. So they wrote that wrong. So the conjugate of that is a -1, but then a -3i. It's the imaginary part that comes the opposite sign. Okay? Just be aware of that. Be careful. I don't think they'll trick you on that, but I don't want to tell you that they won't ever. It's the I part that becomes the conjugate. The I part. Because when you multiply an I and an I, you get I squared, and you know that I squared is a -1. Well, you should remember that, I hope. A polynomial of degree n has exactly n complex zeros. The graph of the polynomial function is shown above. It is known that I square root of 3 is a 0. If f has a degree n, what is the least possible value of n? Let me read that again. The graph of the polynomial is shown. It's known that I square root of 3 is a 0. You don't see I square root of 3 on here because it's imaginary, but you also know what? I square root of 3 is 0, then it has to be negative I square root of 3 is also a 0. So I square root of 3 is a 0, negative I square root of 3 is a 0. 1 is a 0, but 1 is a 0 twice because it's a bounce. It has a tangent line. And 3 is a 0. So that is a 5th degree polynomial. That has to be a 5th degree polynomial. 1, 2, 3, 4, 5. One, two. 2 plus 1 plus 1 plus 1. I guess I should have said 2 plus 1 plus 2. It could be higher than that. It could be higher than that. It could be a 7th degree polynomial. It cannot be a 6th degree polynomial. because the ends are going opposite directions. Plus, you can see all the zeros, and so if there's another imaginary zero, there has to be two imaginary zeros. Polynomial, when we write f of x, we're referring to the y value. If f of x is greater than 0, that means that f of x is above the x-axis. If f of x is less than 0, this is the less than symbol. It looks like an L. This is greater than. It looks like a 7, G-R-E-A-T-E-R, greater, below. The less than looks like an L. The greater looks like a 7, G-R-E-A-T-E-R. So, where is f equal to 0? Uh-oh. Let's change that to something I can write with. -3, -1, 3. That's where it's equal to 0. Where is f of x 7, 0, greater than 7? Well, it's greater than here. So from -3 to -1, I don't like brackets there because you already told me it's equal to 0 there, and equal to 0 is not greater than 0. And it's from 3 to infinity. If you don't like writing interval notation, put x less than -1, greater than -3, put x greater than 3. Either one of those is acceptable if they don't tell you. Oh, this one says less than or equal to. This one says less than or equal to. So less than is going to go from -infinity. I'm assuming those are arrows. If they don't have points on there. -infinity to -3, but that needs to be a bracket. Infinities never have brackets. Infinities never have brackets. And then it's also from -1 to 3. If you would rather write it, you would say x less than or equal to -3, x less than 3 equal to, greater than, equal to -1. Either one of those is acceptable because they didn't tell us which way to write it. Too fast, too slow, everybody okay? This is new. This is new to you guys. Inequalities. You have solved equalities or equations before. Now we're going to solve inequalities. So I just solved for it equal to 0. So we look for it equal to 0. We're going to create a sign chart. Get used to sign charts. You're going to have to get very comfortable with sign charts. I'll show you how they are in just a second. They're pretty easy to, they're not that big of a deal, but you just got to learn what they are. Test values. So we're going to test a value and then interpret the sign of chart to answer the given inequality problem. So this is kind of giving you the steps. It's harder than it looks than it is. This looks harder than it is. Okay? Be sure to write your answer in interval notation and think about endpoints. Okay, so example number 4. 1, 2, third degree polynomial. I can see all the zeros. It's already factored for me. If it's already factored for me, it's really, really, really nice. So I'm going to draw a number line. Typically not that big, but I'm just kind of emphasizing. Just a number line. The smallest up here is going to, the smallest 0 is -4. So I put it first, -4. The next one is -1, and I don't care where you put -1, just don't put it to the left of -4. And the next one is +3. And I don't care where you put +3. Just don't put it here or here. Those are equidistant. It looks like they're equidistant. These are not equidistant. -1. Oh, yeah, no, that's 4. This distance is only 3. That distance is 4. I don't care. They don't care. They don't care. You labeled it. Now I'm going to test points. So test a point left, -5, -6, -7, -200. They don't care. Just test it. Test a point here, test a point here, and test a point here. So I've got to test 1, 2, 3, 4 points. You got to test it. And here's what's nice. I don't care what the value is. I just care if it's positive or negative. I don't care what it is. So it doesn't take a whole lot to check it. -5, -6, -7, -200. -200 makes that number negative. -200 makes that number negative. And -200 makes that number negative. And I don't care what that number is. If it's a negative times a negative times a negative, that number is a negative, and that's all I care about. Somewhere. Some put it down below, some put it up above. Just put it somewhere. Everything to the left of -4 is going to be a negative value. Everything. If I put in -5, that's going to be negative. That's going to be negative, and that's going to be negative. -5 minus 3 is the negative. -5 plus 1 is a negative. -5 plus 4 is a negative. Barely, but it's a negative. And a negative times a negative times a negative is a negative. I don't care what it is, it's negative. -2, -3, whatever you want. Don't use -4, don't use -1. -2. -2 makes that negative. -2 makes that negative. -2 makes that positive. So when a negative times a negative is a positive, positive times a positive is a positive. So everything between here and here is a positive. And we just keep checking. Keep checking. That must mean that this is a cross. Like I could actually almost sketch this and do the same thing, but I'm teaching you number charts too. Next one. Between -1 and 3, 0. I'm always going to use 0 if I can. That's negative. That's positive. That's positive. That's going to give me a negative. It becomes a little bit quicker. Something bigger than 3, 4, 5, 6,000. That's a positive. That's a positive. That's a positive. And a positive and a positive and a positive is a positive. Y'all okay with my sign chart? I want what? Everything bigger than 0. Well, if it's bigger than 0, it better be positive. So I don't want these. I want these. I don't want these. And I want these. So I need everything from -4 to -1. Parentheses, not brackets, because brackets make it equal. And then I want everything from 3 on. Yes, no, maybe. If you wanted to, you could sketch that. Because you know -3 or +3 is a 0. You know that -4 is a 0 and 1 is a 0, and your end behaviors are going to do this, and it's just a crosses on every one of them. And it's positive above the x-axis, and it's negative below the x-axis. Number line. -2, 5. I only need to test 3 points. 3 points. 1 to the left, 1 in the middle, and 1 to the right. -2, -3, -4, -5, -200, whatever you want to test, it doesn't matter. -3, -3 minus +2 is a negative number, but that negative gets squared. So that's positive. And then the -3 and a -5 is a negative, and a positive times a negative is a negative. -2 to 5, that's 0. 0 plus 2 is 2. 2 squared, 4. I don't care. It's positive. That's negative. Positive times a negative is a negative. That's because you guys know that this -2 is a bounce. And so it must be coming up and bouncing and coming back down because it's still below the x-axis. And my guess is at 5, I'm going to go back up the other way. But let's test it. 6. That's going to be positive because you're squaring everything. It's always going to be positive. And that 6 is going to make it a positive. And a positive times a positive is a positive. I want it where it's below 0. And it's below 0. Oh, it's okay to be 0. It's okay to be 0. So guys, they'll ding you for this. If you go from -infinity to -2, and then you go from -2 to 5, you're wasting lead. You might as well go from -infinity to -5 or to +5. -infinity. That's +5. There you go. I'll cheat. Bracket. I keep wanting that negative sign to make it a -5. Maybe the negatives are better to put it up top. Yes, no, maybe. Sign charts. Get used to those. We'll use those a ton this year. We solve a lot of inequalities. When you see inequalities, that's the best way to solve them. Sign charts. Find out when it's equal to 0, and then look at positive or negatives. If the table of values with equal width input intervals, we can determine if a degree of polynomial by examining the successive differences in the output values. The number of successive differences needed in differences of constant is equal to the degree of the polynomial. Positive. No, negative. -1, went down 1, went up 2, up 4 or 5, up 8, 2, 2, 2, 2. I always check my x values just to make sure they're constant. From here to here is 3. From here to here is 3. From here to here is 3. Determine the degree of the polynomial represented. It took me 2 times to get constants. It's quadratic. It'd be cubic. If it takes you 1 time, it's linear. 2 times quadratic. 3 times linear. 4 times, they better put a whole bunch of numbers up here to get the differences to be 4. Okay, quad. The second differences are constant. That's all I have to say. The second differences are constant. 3, 3, 3, 3. You're getting bonus stuff. Other teachers don't tell you to do that X stuff, and it's going to get you on one of these tests. I went up 2. I went up 10. I went up 10 and 27 is 17. Holy cow, now I went up something 3. 23? 33. 23. Up 8, up 7, up 6, 1, 1, cubic. Degree, 3. Sorry, it asked me for the degree. How are we doing? Close. Oh, even and odd. Even and odd. Even and odd. If f of negative x equals f of x, it's an even function. It has to be an even degree, but all even degrees are not even functions. It has to, listen to what I'm saying, that's not an if and only if y'all ever learned that in geometry. If and only if means if it goes this way, it has to go this way. It doesn't. If it's even, it could be an even function. Even functions have to be even degrees. Even functions have to be an even degree. So that's an even degree. It could be an even function. Doesn't have to be. Okay? What that means is every point over here better have a mirror on the other side. Better have a mirror on the other. I better be able to fold that on the y-axis and get a mirror image. If you fold it on the x or y-axis, y-axis, it better be a mirror image. If it is, then it's an even degree. If they give you the well, they'll do that in a second. An odd degree means that if I plug in -2 and I get 2, I better plug in a +2 and get a -2. Everything has to be opposites. So if this point is -2, 2, I better have a +2, -2. This is -3, well, it's -3, 0. -3, 0. I better have a 0, 3. I'm sorry, I better have a +3, 0. Flip signs, +3, I did inverses. +3, 0. It has to be symmetric to the origin. So in order for a degree to be odd, it's got to go through the origin. If it doesn't go through the origin, it's not. It has to go through the origin. And then you're going to fold. Fold on the x, then fold it on the y. Or fold it on the y and then fold it on the x. It has to be a fold. It's symmetric to this line. Beautiful. Okay. Odd, evens. Here's how I do this. Determine if it's even, odd, or neither. This can't be odd. Can't be odd. I just do f of 1. It's the easiest one to do. 1 times 1 times 1 times 1 times 1 is 1. Times 2 is 2. 1 times 1 is 1. 2 minus 1 is 1. 1 plus 5 is 6. Okay with that? And then I'm going to do f of -1. -1, -1, -1 is 1. 1 times 2 is 2. -1, -1 is 1. 2 minus 1 is 1. 1 is 6. If I got anything else besides a +6, it's not even. It can only be even. It can't be odd. It's impossible for that one to be an odd. Impossible for that one to be an odd. It's impossible for that one to be an even. Now, I don't know if it's odd. F of 1. 1 times 1 times 1 times 1. 1 plus 3, 4. 4 minus 1 is 3. Okay? F of -1. -1, -1, -1 is -1. -1 minus 3 is -4. -4 minus 1 is -5. What would I have to get for it to be odd? -3. If I plug in a +1 and get a +3, and if I plug in a -1, I got to get a -3, and I didn't. Neither. There's a whole lot more neithers than anything else. That's easy. When they give me the graph, it's easy. That's an odd. odd. Neither. Neither. I can't fold it on this and get a mirror image. Your worksheet tonight, okay, this is worksheet A, worksheet B, worksheet C. C, you do not have to do D. Or it showed up somewhere. D. E. It looks like a lot, but it's big pictures. You do not have to do E. E is more solving the sign charts. So if you want more of that, it's there. I'm not making you do it. Y'all okay with what I'm saying? Beautiful. Beautiful. Let me hit stop or use up all my bandwidth.